Hi friends, this is Chetan from Chetty Networks, where statistics lose. Friends, today let us discuss about mathematical expectation. First of all, let us discuss about what is random variable. It's a measurable function from sample space omega to measure a measurable space C. That is, it assigns a value from the sample space to a set of values from real numbers. It is a one-to-one function from sample space to real number. So this is nothing but a random variable. So random variable is a function from set of it assigns the values from sample space to real number. Okay, and let us look at what is mathematical expectation. It is weighted average of all possible values of a random variable, and weights are the probabilities associated with this, and this can be given by expectation of x is equal to summation of x into p of x, where if x is a discrete random variable, then you are going to take the summation. If it is continuous, then you are going to take integration of f into f of x dx. So this is what is expectation of a random variable, and I will discuss in detail about the random variable in later part. And the properties of expectation are, if there are two random variables x and y, then expectation of x plus y is equal to expectation of x plus expectation of y. And in general, you can say expectation of summation of xi, I running from 1 to n, is nothing but summation of expectation of xi. So this is what is the property of, this is called as additional property of expectation. And expectation may not always exist, means if this integral is not less than infinity, means this integral should be finite, then only expectation will exist. So for example, if we take f of x equal to 1 by pi into 1 plus x square, where this is a probability density function of a Cauchy distribution, here mean does not exist, because if you take the integration from minus infinity to plus infinity, x into f of x dx, that is, you get this term, that is 1 by pi log of 1 plus x square, and this limit tends to infinity, means this will not converge. So expectation of x does not exist for Cauchy distribution, and I will discuss the various probability density functions and mass functions later. Now, and moving on, if x and y are independent random variable, then expectation of x into y is expectation of x into expectation of y, and you can generalize it as expectation of product of xi is nothing but product of expectation of xi, means that product will come out and individual expectations will be multiplied. So this is if this is possible if and only if this x and y are independent random variables. Then if you want to take the expectation of a constant, it is nothing but constant. Expectation of a constant is constant. If a is a constant, then expectation of this will be a, and expectation of a into x, here expectation of a into x is nothing but a into expectation of x, this constant will come out. And in fact, if you take expectation of a into a function of x, that is phi of x is a, xi of x is a function of x, then a will come out, and expectation of xi of x, means expectation will be there only for the random variable. Okay, and moving on, this is also one of the properties, expectation of phi of x plus a is expectation of phi of x plus, means expectation of a is a only. So this is how it is, and therefore expectation of a linear function is same as that of linear function of expectation. If you want to take, see, this is how expectation of g of x is nothing but g of expectation of x. For example, if you take g of x equal to ax plus b, then if you take the expectation of g of x, that is a into expectation of x plus, since b is constant, b is as it is, and g of expectation of x, if you take the expectation of x first and then put the function g, it is nothing but the same. So this is also one of the important properties. And xi's, if xi's I ring found n are random variables and ai's I ring found n are constants, then expectation of summation of ai xi is nothing but summation of ai into expectation of xi, or the sum should be less than infinity. And if x is greater than or equal to 0, that is if a random variable is like of x is greater than or equal to 0, then expectation of x is also greater than or equal to 0. And if x and y are two random variables such that if y is less than or equal to x, then expectation of y is also less than or equal to expectation of x. So this is how. And the proof is like this, that is if y is less than x, then y minus x is less than 0, that is x minus y is greater than 0. And if you take the expectation of x minus y is greater than or equal to 0, and hence this expectation can be split individually, expectation of x minus expectation of y, this is also greater than 0. Therefore expectation of x is greater than expectation of y. That is, if x is greater than y, if x is greater than or equal to y, then the expectation of the same is greater than or equal to expectation of this y. Okay. And moving on, if you want to take the expectation, the absolute value of expectation is less than or equal to expectation of the absolute value of x. So the proof reads like this. If x is less than, means you know that x is always less than or equal to absolute value of x. Since if you apply, if you know that if x is less than y, then expectation of x is less than expectation of y by the previous property, you can apply that here and you say expectation of x is less than expectation of absolute value of x. And similarly, you know that minus x is less than absolute value of x, and expectation of minus x is less than or equal to expectation of absolute value of x. And combining this and these two results, you can say that absolute value of expectation of x is less than or equal to expectation of absolute value of x. And friends, these properties will be used to solve problems. And one more property is, if mu r dash exists, that is then mu s dash exists for all 1 less than or equal to s less than r. That is, mu r dash means expectation of x to the power r. If this exists, then expectation of s to the power x to the power s exists for all s less than or equal to r and greater than 1. So this is the next property. And if x and y are independent random variables, then expectation of h of x dot k of y is nothing but it is equal to expectation of h of x into expectation of k of y, where h dot is a function of x and k dot is a function of y, provided both the expectation exist. Means if you want to take the multiplication of functions of random variable here, then you can get the individual expectations. And further moving on, variance and covariance of a random variable. So if x is a random variable, then variance is given by, variance of a random variable is given by variance of x is equal to, it is nothing but expectation of x square minus expectation of x whole square. So this is nothing but variance of a random variable. And the properties of variance are like this. If you want to take variance of a constant, a is always 0. Variance of a constant is always 0. Friends, first of all, let us know what is variation is. I will give a simple example. If a bowler on an average bowls around 145 km per hour, if a bowler bowls at this speed, it doesn't mean that he will bowl all the balls exactly at this speed. He may bowl at 144.9, or he may bowl at 140 plus, or he may bowl at 148. Means he will be bowling around the range of 145. Means his bowling average, the speeds will be distributed around these points. So if you measure that what are the points, see, if this is 145, this is average value, and he may bowl more than this or less than this, or he may bowl exactly like this, but not all the balls he can bowl like this. So this is what is the scatter, means this is what is the dispersion from this mean value. So expectation of x minus expectation of x whole square, this is nothing but the squared deviation of the random variable with respect to its mean. The expectation of squared deviation of the random variable with respect to its mean. This is nothing but variance of a random variable. So you may see that this variance at most it can be 0, means it is always greater than or equal to 0. Variance cannot be negative, because since it is a dispersion, this is at the maximum it can go till 0, means at the minimum it can go till 0, and it is greater than 0. So this is what is the concept of variance. And if you multiply a random variable with a constant, and if you want to take the variance of this is nothing but a square into variance of x, means this constant will turn out as a square, and then variance of the random variable is taken, and the variance of a constant is always 0. And you may say that variance is not independent of change of scale, means if you multiply a, this is nothing but scale factor, so this a will come out as a square, as you know. So this is not independent of this, means this variance will always depend on the scale. So that is all, this is also one of the properties. And one more thing is, variance of x plus b is nothing but variance of x itself, because variance of x plus variance of b, since b is a constant, the variance of a constant is always 0. So variance of x plus b is variance of x. See here, it is independent of b. Independent of b means it is independent of location, okay, or independent of origin, you can say. And one more property is, if you want to take the summation, summation ai running from 1 to n, ai xi, see variance of this term will be given by this term. And if you take the variance of summation of ai xi, then it is nothing but it will be given by this expression, that is summation of ai square into variance of x, and summation of ai aj double summation, and I is not equal to j into covariance of xi xj. And if you want the covariance of two random variables x and y, it's been given by this expression, that expectation of x minus expectation of x into y into expectation of y, and that is nothing but that's equal to expectation of xy into minus expectation of x into expectation of y. And moving on, you need to note these points, that if x and y are two independent random variables, then covariance of xy is 0. So first of all, what do you mean by covariance is, it measures the relationship between two random variables x and y. Suppose if we have height and weight, so what is the relationship between height and weight? It will measure that. And if you want to measure the relationship between income and expenditure, how these income and expenditures are related, so that will be measured by covariance, okay. And if x and y are independent, then covariance is 0. And you can see covariance of ax comma by, second property, that is nothing but ab into covariance of xy, and covariance of x plus a comma y plus b is nothing but covariance of xy, that is see here it is independent of a and b, so independent of change of origin. And if you change the scale will appear here, that is covariance of x minus x bar, the fourth property, and y minus y bar divided by sigma y. Sigma y is standard deviation of y. Standard deviation is nothing but square root of variance of a random variable is nothing but standard deviation, okay. So that standard deviation, that scale factor will appear as it is, and this locations factor will not appear. So covariance of xy divided by sigma x into sigma y, okay. And covariance of x plus z comma x plus y comma z is nothing but covariance of xz plus covariance of yz, and covariance of ax plus by comma cx plus dy is nothing but say ac into variance of x. Covariance of x comma x is nothing but variance of x. So I need to note this. And AD into covariance of xy plus BC into covariance of xy plus BD into covariance of means variance of y. And let us solve a problem. Suppose if x is a real valued random variable, which of the following values cannot be expectation of x and expectation of x square respectively. This question has been asked in GATE 2013. Options are A 01, B 23 and C 1 by 2, 1 by 3, D 2 and 5. Friends, you know that variance of a random variable is always greater than or equal to 0, and you know the expression that variance of a random variable x is given by expectation of x square minus expectation of x whole square. So, you have to substitute the values and see for which value it is giving greater than or equal to 0, and here answer is B, because for B this variance of x is greater than 0, this condition is not satisfying. So, this is the answer, means which values cannot be obtained. So, answer is B. And moving on, conditional expectation and conditional variance. The conditional expectation of a continuous function g of x comma y given y equal to yj is defined by this expression. So, this is nothing but expectation of g of x comma y given y equal to y is nothing but if you have continuous distribution, then you have to go for integral or else summation. Okay, and this is given by this expression, and variance of conditional variance is given by this expression, and you have to note that the conditional expectation and again expectation is nothing but expectation of x. See, if you have expectation of x given y, this is conditional expectation, and again you are going to take the expectation of this. So, this is nothing but expectation of x, and variance of x in terms of conditional expectation is given by this second note. That is, variance of x is nothing but expectation of variance of x given y plus expectation of variance of x given y plus variance of expectation of x given y, and third one is conditional covariance of x comma expectation of y given x. That is nothing but, see, you can see by the proof that covariance of any two random variables is nothing but it is xy into expectation of x into expectation of y. So, that is expectation of x will come out, and expectation of y given x is nothing but its expectation of y. So, this can be given by this expression, and similarly covariance of x y is nothing but covariance of x comma expectation of y given x. And one more thing is expectation of x square is if it is less than infinity, then variance of x is greater than variance of expectation of x given y. And let us look at one more problem. If expectation of x given y is a conditional expectation of y given x, then expectation of x y is 4 options are given, and this question has been asked in KSET 2013. So, you know expectation of x into expectation of y given x. So, this is nothing but you take the expectation inside, and expectation of x into conditional expectation of y given x, that is nothing but, see here it is expectation of y, and if you take the expectation of outside, this is nothing but expectation of x y, and answer is B. So, it is very simple, and this question has been asked in KSET 2013. And next question, it is the question which has been asked in KSET 2015. If probability of x equal to k, and k is equal to k by 15, and k takes the values 1, 2, 3, 4, 5, which of the following is equals to expectation of x given x greater than 3, and 4 options are given there. Let us solve this by taking an event a that is equal to that is x greater than 1, and you know that conditional expectation is given by expectation of x given a is nothing but you have to take the summation of x into probability of conditional probability you have to take. So, the conditional probability, you know that by previous formula or base theorem, expectation of x intersection a divided by probability of a, and you know probability of a is nothing but probability of x greater than 1, and the probability of x greater than 1 can be obtained by 1 minus probability of x less than or equal to 1, and since x is taking only the values from 1 to 3, so it is nothing but probability of x is equal to 1, So probability of x is equal to 1 is, put k equal to 1 in this expression. So x equal to 1 is 1 by 15. So 1 by 15 and 1 minus 1 by 15 is 14 by 15. So probability of A is 14 by 15, and you want the numerator is, it is x into summation of x into probability of x intersection A. So x intersection A is x is greater than 1. So greater than 1 is 2, 3, 4, 5. So I have to put the corresponding values and take the summation, that is 54 by 15, and the answer is 27 by 17, and this does not match with any of the options. So this is a grace marks. And let us solve one more problem. If A is a random variable with mean 5 and variance 4, then mean and standard deviation of 4x plus 5 are. This question has been asked in case of 2016. It's very simple. You know the properties of expectation. Expectation of x is 5 and variance of x is 4. It's been given. So expectation of 4x is 4 will come out, and expectation of x goes inside, plus expectation of a constant is constant, and you have to substitute the values and get the values. And variance of 4x plus 5. So this variance of 5 is 0, and the variance of 4, this 4 will come out as a square. So 4 square into variance of x, that is 16 into 4, 64, and they have asked the standard deviation. So square root of a variance is nothing but standard deviation. So square root of 64 is 8, and answer is D. And let us solve one more question. If f of x is given by 4 by pi into 1 plus x square and 0 is less than x is less than 1 is a PDF of a random variable, then what is the expectation of x? You know expectation of x for a continuous random variable is given by integration of 0 to 1, or the range of x, that is the range of x is 0 to 1 here. So 0 to 1 x into f of x dx, that is equal to 0 to 1, and what is f of x? It is 4 by pi into 1 plus x square, and multiply 2 in the numerator and denominator. So you can use the formula integration. If you want to multiply a random variable with c, then this will be like this: mcx of t is nothing but mx of ct, and the proof is expectation of e to the power ctx, and this c will come out. So this is given by this formula. And if you want sum, that is m of x1 plus x2 plus so on plus xn of t, if you want the momentary function of this, that could be given by product I running from 1 to n m x I of t. So if you want the momentary function of the sum, then you will get the product. And if you change a random variable by if the scale location and scale, and you put this equal to u, and you want m u of t, this will be given by this expression. So this is very important. It will be used to solve the problem. So remember this expression. And there is a remark: the moment genetic function of a distribution, if it exists, it determines the distribution uniquely. Means for a probability distribution, there is only one, or there is a unique moment generating function. If moment generating function exists, then it determines the probability distribution or density function uniquely. Okay, that can be given by if mx of t and my of t, if these two moment generating function are equal, then x and y are identical. Identical means they are same, they are similar, and they have the same probability distribution or density function. And I thank you for watching this video, and I hope these videos will help for your preparation. Thank you friends, thank you for watching my video. Have a nice day.